So good morning everyone. Good morning students. How are you all? Is everyone is fine? Yes, good. So the last class we have discussed about the introduction part of electrical conductivity of liquid. Electrical conductivity of liquid. So when we observe the electrical current, when we read the lesson electrical current in the 6th class and 7th class, we learn that electrical conductivity in solid we know very well. So in the last class, we have discussed that how electrical current is a passed in the electrical current is passed in solid. For that, what we did, we used some materials. What are materials we are used for doing the activity? For that, we use a battery, conducting wire, LED bulb, and safety pin, plastic, plastic paper or polythene cover, and chalk piece we are used. Means here, how the electricity is conducted, how the current is conducted in solid we learn. Is it clear? We observe the electrical current in the solid. So our lesson is the electrical conductivity of liquid. Means how electrons are passed in liquid. So in the last session, in the last class, we learned that water is a good conductor of electricity. Means water allows the electrons. Water allows the electrons to pass. Whereas Whereas distilled water, if we observe the pure water or distilled water is a bad conductor of electricity. It is a bad conductor of electricity. So why it is a bad conductor of electricity already we have discussed. Once again I am repeating. So here the normal water or drinking water or bore water or well water. These are good conductors of electricity. Why? Because here, if we observe the normal water, it has some minerals or impurities. Is it clear? So here, the minerals or the impurities are the reason for electrical conductivity. Whereas if we observe the distilled water or a purified water, pure water, it is a poor conductor of electricity, means it doesn't allow the electrons. Why it is not allowed? If we observe the distilled water, it is a pure water. It is not have any minerals. It is not have any impurities. We know very well that impurities are the minerals that play an important role for the conductivity of electricity. Whereas in the pure water or distilled water, it is not have any impurities. That's why distilled water or the pure water is a poor conductor of electricity. Is it clear? So see, once open your textbook and see page number 120. Page number 120. Yes, my dear students, did you open the book or not? Yes. The page number 120. Electrical conductivity of liquid. Electrical conductivity of liquid. So see first one, sometimes we read in the newspaper about the farmers getting electrical shock while starting water pumps of wells, especially because of contacts made with the switches or starters by wet hands. You have to underline the wet hands. If the farmer hands are dry, if they touch the switches or starters, there is no problem. So in the overlook or maybe something, if they touch these switches and starters with their with their wet hands. So what happens? They're electrically short circuit. So here, why the wet hands are pass the electricity? Because of wet hands means the hands has some water. The hands has water. So if the water is the reason for electric shock. And see the second paper, our elders, see your question. Do you know the reason behind getting the electric shock while working with the wet hand? Yes, we know. Here, wet hand, the water plays a role to pass the electrons to our body. Next one, our elders cautioned us about the touching electric heater immersed in the water. They said that don't touch the electric heater. Don't touch the electric heater which is immersed in the water. Why? Why? Because of the what means here electric heater pass the electrons into the water to heat the water. So means if you place your hands or anything in the water, so what happens? So electrons are passed to your body. Means you are electrically shocked. That's why our elders said that don't go near to the electrical heater. So be careful. And you, in the early classes, that is 6th and 7th class, we will learn that how the electric current is passed in the solid. So in the activity 1, already we had discussed. Before that, electrical conductivity in solid. That already we have discussed the last classes, the last year 6 and 7. If we observe here, in the activity 1, water metals we are taking water metals. So here the metals required is we require battery, we require the battery, conducting wire, we require conducting wire, battery, conducting wire, safety pin, or maybe iron, plastic, pencil lead, or topic, all these we are used as a material and LED bulb. Here these materials we are used to do the activity 1. To do the activity 1, we require the materials battery, LED bulb, conducting wire, and safety pin, iron nail, or maybe plastic, paper, or maybe carbon paper, or topic, pencil lead, all these we are used. So here, already we know that one end of the battery is connected to conducting wire. The two ends of the battery wire is connected to conducting wire, and one end of the conducting wire is connected to LED bulb. The other end of the LED bulb is connected to electricity or iron nail or plastic or paper or anything. So the remaining end is connected to LED bulb. So what we observe? So when the two ends of the conducting wire are connected, so what happens? We observe that glowing of LED bulb. LED bulb is a glow. In between the conducting wire, if we place the safety pin, so what happens? We observe that the bulb is glows. Instead of the safety pin, if we use the iron nail, so what happens? Is the bulb is a glow? Yes, LED bulb is glows. So instead of the iron, if we use the plastic, polythene cover or the plastic, so what happens? Is the LED bulb is a glow? Is the LED bulb is a glow? No. If you use a pencil lead, pencil, lead. So what happens? In between the two conducting words, if you use the LED, pencil lead, sorry, pencil lead. So what happens? We observe that here the bulb is glows. So why the bulb is glows if we use the pencil lead? So means here the pencil lead has graphite. Has a graphite. So graphite is a good conductor of electricity. Graphite is a good conductor of electricity. That's why if you use a pencil ray, instead of the iron ray and specifically the place with the two conducting wires, what happens? We observe the glowing of the LED bulb because of the pencil ray is made up of graphite. So graphite is a good conductor of electricity. So why graphite is a good conductor of electricity? Why graphite is a good conductor of electricity? Because if you observe the structure of the graphite, so here, for example, here is the structure of the graphite. These are the layers of the graphite. So what happens here? Between the layers has two pi bonds. Between these are the layers of the graphite. So this you like in your 10th class. These are the layers of the graphite. What happens? Between the layers of the graphite, we have two bonds. Two bonds. So these bonds we call as a pi bond. Pi bond. So pi bond is the reason for the conducting. Okay, now pi bond is a reason for conducting electricity. Here, graphite, why graphite is conducting electricity means between the layers of the graphite has a pi bond. Because of layers of the pi bond, graphite conducting electricity. Is it clear, everyone? Okay, let us see here in the page number 123rd paragraph. In the early classes, you learned that electric current can pass easily through metals like the copper, aluminum, iron. Okay, now iron, aluminum, copper, zinc. So, I am writing here copper, iron, aluminum, zinc. So, if we use these materials or metals, what happens is observe the passing of electric current. Okay, now, so all metals are not conducting electricity. Some metals are poor conductors, they not allow the electric current. Is it clear? The best example is the gold, platinum, silver. So these are the bad conductors of electricity. Is it clear, everyone? So see the page number 120 in the table. Serial number, object, material, bulb glows, yes or no, good conductor or a bad conductor. So here, what the objects we take, what the metals we are used. See in our textbook, nail. We are using the iron nail. See the bulb is glowing or not? Yes, bulb is glowing. So instead of the iron nail, if we use the eraser, if we use the object eraser, if you place the eraser in between the two conducting wires, so what happens? Is it bulb? Is bulb glows? No. Yes, very good. The bulb is not glows if we use a eraser. So instead of the eraser, if you use a pencil lead, is the bulb glows? Yes, very good, Hasini. Bulb is glows. Good, Sai Bhavan. Yes, good. Instead of the pencil lead, if you use a plastic cup or maybe plastic or maybe paper, normal paper, is the bulb glows? No, very good. So I'm writing the materials one by one. First one, First one, iron nail is a burglar. Yes. Eraser. No. Pencil. Yes. Plastic or maybe paper. What happens in the burglar? No. And the fifth one. So what are we have to take? So here, take a stick, wooden stick. If you place the wooden stick between the two conducting wires, if you place the small stick between the two conducting wires, the two conducting wires are connected by the stick. Is the bulb lost? Yes, good answer. No, the bulb is not lost. Last one I am taking here, the stick. I am using here chocolate. Is the bulb lost? Yes, very good. Bulb is not lost. So why? Because here iron nails give the permission to flow the electrons through it. Whereas eraser doesn't. Pencil is yes, it allows the electric current. So here, if you observe, iron nail and the pencil give permission or allow the electron to pass through them. Whereas here, eraser, plastic, stick, and chocolate will not allow the electric current to pass. From this, we can say that some materials that allow the electric current, some materials are doesn't. So the materials which allow the electric current to pass through them, we call as a good conductors of electricity. The materials which does not allow the electric current, we call as a insulators or bad conductors of electricity. From this, we can say that iron, septic, and pencil is a good conductors of electricity. Whereas eraser, plastic or paper, wooden stick or chocolate, all these are bad conductors of electricity. In the last class, already we have discussed the semiconductors. Semiconductors, the examples of semiconductors are we are having silicon, symbol is Si, germanium, symbol is G, gallium, symbol is Ga, indium, silicon, germanium, gallium, indium. These are the semiconductors. Silicon, germanium, gallium, indium. These are semiconductors. Means here, the materials which allow the electrons to flow through them, we call as a good conductors of electricity. The materials which does not allow, we call as a bad conductors of electricity. Semiconductors not given in our textbook, you learn. So semiconductors we can change into good conductors by making diodes. PNP diode, NPN diode, you learn your internet. Is it clear? Semiconductor we can take as a good conductor by making some diodes. Is it clear? The best example for the semiconductors are silicon, germanium, gallium, and indium. Is it clear, everyone? So see, once in the textbook is definition is given. Materials, see the page number 120. Materials allow electric current to pass through them. We call them as a good conductors of electricity. So here in general, all metals are good conductors of electricity. In general, all metals are good conductors of electricity. On the other hand, the metals that do not allow the current to pass through them are called as a bad conductors or poor conductors of electricity. So from this we can decide which is a good conductor, which is a bad conductor. So electrical. So here think and discuss why some materials allow electric current to pass through them and why some do not. Okay, now if we go to the deep of this matter, so here because of unpaired electrons, because of unpaired or empty shells present in the metal, what happens? They flow the electrons that will learn the electric current in the 10th class. Okay, now. So see finally here, electrical conductivity is the property of any given material. We can say that a material has good electrical conductivity if it allows the electric current to pass through it easily. We call it a good conductor. So which does not is a bad conductor. So in the next lesson, we are going to discuss about a electrical conductivity in the liquid.